Hi, everyone. Welcome to how Foundry integrates with open source frameworks and technology. My name is Facundo, Principal Product Manager at Microsoft, and today I'm joined by Nagkumar, Senior Software Engineer also at Microsoft, who's going to be driving the keyboard. So today's question is super simple. If you build an agent using an open source technology, how you package and deploy that to production without having to rewrite it? And for that, we brought you, hopefully, an interesting setup. So I'm pretty sure all of you are familiar with OpenClaw, these general purpose agents that can browse the web, they can search for emails, they can do stuff for you and whatnot. So today, we're going to build our own OpenClaw live using open source frameworks and technologies. And then deploy it to Microsoft Foundry to take it to production. So let's get started. Let's start from the bottom, Nagkumar. If I want to build an agent with no magic platform, no Foundry, what is the minimum amount of code that I need to get it done?
At the core, we need a model and an agent loop. An agent loop is what keeps the agent moving. It asks the model for the next step, runs tools when needed, and uses each result to decide what happens next. This file is intentionally small. The model comes from LangChain's init chat model, and the loop is built with create deep agent. The important point is that this is simple LangChain LangGraph style code. Most of the Foundry models expose OpenAI-Compatible APIs, so LangChain can talk to a Foundry model using the same protocol it understands. Changing the model target is configuration, not a rewrite.
So you're saying that in this case, LangChain owns the agent loop via that create deep agent function, and then Foundry provides the models via the OpenAI-compatible protocol, right?
Right. I'll run the small local agent first. And if I see this and say hello, we can see that the agent replied back.
Okay, well, so this is useful, but of course, it cannot do anything outside of what the model already knows, right? So one of the reasons agents like OpenClaw are so popular is because they can get things done, right? So what's the open source pattern that we should use to get this agent to do stuff for us?
The open source pattern is MCP. Model Context Protocol is an open protocol that lets an agent discover tools and call them. For this demo, the MCP server is 𝗦𝗽𝗀𝗀𝗀𝗀𝗀, which gives the agent access to Microsoft 365 mail capabilities through a tool interface. The agent does not need to know every HTTP endpoint that Microsoft 365 exposes. It connects to the 𝗦𝗽𝗀𝗀 MCP server, asks for tools, and then receives the tool schemas like search messages, get message details, draft replies, and so on. To show you how the code looks like,
so this is a different agent, but now with the MCP.
Yeah.
Okay.
And then we see that the URL is being passed from here, and we go back to the same agent loop. And we are just adding them as tools.
So you're saying that I can take any LangGraph agent that I already have, point into this MCP server using the open source protocol, and get access to 𝗦𝗽𝗀𝗀𝗀, mail capabilities, calendar capabilities, Teams, and whatnot, right?
Yes. Let me show you how to run this. So here's my agent with the MCP enabled, and I'm going to ask it to check my email. While the spinner is moving, watch the tool boundary. The agent discovered that mail tools at runtime and chose the right one. We are also keeping the output kind of sort of clean. Now, the same local agent can call Microsoft 365 through MCP. The tool boundary is inspectable, and the agent is just normal Python code.
Awesome. Yes, we can see it came back. Like, it find five emails through the 𝗦𝗽𝗀𝗀𝗀 MCP server. So this is useful. The agent has hands, but this is nothing interesting in the sense of it doesn't save me time, right? Knowing which are the emails that I haven't read is not that special. Maybe what I want is this agent to triage my inbox, which require knowing a bit more about how to use each and every tool. What's the open source pattern that we can use here to teach our agent how to use this?
This is where skills come in. Tools are like verbs, search messages. A skill is a playbook, like triaging inbox, which can pull some fields, classify the emails into categories, assign priority, and draft some replies when asked. I'm going to show you how to run the skills agent. So this one's my agent with skills, and I'm going to ask it to triage my inbox. And while this agent is running, we can also take a look at,
we can say that it pick up the triage skill, but like, and we can see it start using some tools, but how the agent actually came across with this skill that you're mentioning, or how it discovered it?
So the agent uses this skill document. This skill is just a markdown document with a small formatting block. There is no special service or proprietary schema. The agent reads it when the prompt is relevant. Now, if we look at the skills, you can see that we mount the skills into a virtual skills path. The agent can list it and look at it when it needs guidance. Now, let's go back to the terminal and see what's going on.
We can see that the agent is still running, but something interesting to see, now we see multiple tools being called, different from what we saw before. Only one tool was called out. And we can even see like tools like get message, which it looks to be searching for the actual content of the email, which makes sense, right? Like you cannot triage an email without knowing a bit more about what is inside of it or what was the specific request. We can see it came back, and now we got a triage summary, which are the important things that I need to look out, which is the category, which is the recommended action, and which are the reasons for having that action, right? Like, so this is way different because it's the same model, it's the same tools, but the behavior is completely different, right? And this is coming from the power of this reusable skill.
Yep, that's the big point. Skills are a lightweight way to make agent behavior repeatable without turning every instruction into a massive system prompt.
That's cool. Another thing that usually you can see in agents like OpenClaw is the ability to browse the web, right? Which opens you a door for doing a lot of other things. What's the open source story if I want to bring that capabilities to an agent using open source technologies?
We can use something called Playwright. Playwright is an open source framework which exposes a CLI utility, and we can also add this skill to kind of teach the agent what to do using that Playwright CLI. Now, if we look at this agent.py here, I've added my Playwright tool to my getTools method and send all the tools within. Now, here's an agent which has that Playwright tool set up, and I'm going to ask it to open Amazon and tell me the price of the first Microsoft branded coffee cup.
Okay, yeah, we can see that now we pick up a different skill. The web browser is using that Playwright CLI tool that you mentioned, plus the MCP server that we have today. But actually considering that, like before with WorkIQ, we connect our agent to an MCP server. Now we're giving the agent access to a CLI tool on the command line. Why did we took this different approach? What is different here?
Yeah, we could have used a MCP server, but browser work usually creates a large tool surface. Here, the command line is a simpler utility. The Python tool has one arg string and an optional browser session. Snapshots and command details only enter the context window when the agent asks for them.
Nice. So what you're saying is that this is not only easier for the model to use the command line to navigate and open a browser, but it's also more token efficient, right? Because like the agent doesn't need to connect to an MCP server, retrieve those big JSON instructions with the method description, the arguments that need to be used, feed back to the model in each and every return, and then generate the response. So I came back, it said I couldn't find a Microsoft branded cup, but the first non-Microsoft Mac that I found is 1619. Well, we don't know what happened, but we need to inspect the trace to know why it didn't found it. So now a fair question from the audience, because everything that you have done so far is running on the terminal. But if our production users probably don't want to be SSHing like your laptop, right? So what's our story to take this to production? How can Foundry help us in this journey?
Exactly. As you said, Foundry hosts the same LangGraph agent as a hosted agent and exposes it through an OpenAI-Compatible Responses API. This file is the adapter layer. Notice that we call the same build agent that we used earlier. And there are two important things. The responses host server, it exposes the LangGraph agent as a responses compatible endpoint. And then we initialize the Foundry server host before we build the graph, so the OpenTelemetry LangChain instrumentation can attach before the graph is constructed.
Nice. So if I'm reading this correctly, so we are wrapping our agent in the Responses API protocol. So this, technically speaking, can run locally in my machine, but also on the cloud, right? So it's the same code, but like can run in both places.
Correct. For the sake of this demo, I had the agent deployed, and then I'm going to send my triage prompt here, triage my inbox.
Maybe zoom in a bit so it's not that
Oh,
small.
yeah. There we go.
Okay, so so we see that the agent is running, but probably, I mean, as it happened just with the browser, that we didn't found the answer that we were expecting. How can I know exactly what the agent did, what were the steps that it performed, and be, let's say, more insightful about how or where or what are the actions that the agent is actually taking? What can we do for that?
Foundry integrates with application insights and OpenTelemetry. The demo uses the Microsoft OpenTelemetry distro and OpenTelemetry GenAI semantic conventions so we can inspect the line graph span, model calls, latencies, captured input and output. So I can head out to the traces tab, and in the traces tab, once we will be able to see all the requests that we've been sending to it. And then we'll also see some more details around how long the request took.
Yeah, and the interesting thing about, like you mentioned, OpenTelemetry with semantic conventions. The interesting thing about that is it's an open source standard, adapted, widely adopted by the industry. So I can use Foundry as we are using right now, but I can use any other tool, Grafana, or any interesting debugger tool that I want to use because the data is open, so I can only focus on its content, right?
Yes. So here you can see the invoke agent span and the chat span from one of the Foundry traces view. You can also do a trace replay and so on. We can also get to see a historical trace, which I had opened up, which can showcase the user input, the user output, all the tool actions that it took. The interesting one is here, it tried to execute a tool to read the skill, which we had asked it to read to know how to, triage my email.
Yeah. This is both because, like, when you are moving things to production, like, this is when you get surprised about, like, where the time that your agent is taking is being spent, and which is all your budget being spent, right? Like here we can see the amount of tokens that each of the sections is taking, so you can know exactly where your money is going, or which are the sections that require most of the maybe improvement or adaptation for your use case, right? Okay, so last question. I know that 2026 is all about like agents calling other agents, composing and whatnot. So what's the open source, let's say, approach here? Can this agent that we just deploy be consumed by other agents? How that will work?
Yes. One of the most interesting things of hosting the agent in Microsoft Foundry is that I get an A2A endpoint that another A2A compatible client can use to discover the agent card and send messages to the hosted agent. Let's see how this works with Copilot CLI. I have Copilot CLI and asked it to talk to the agent, and I can ask it to triage my inbox. And while this is working, we can see how the setup is being done.
Yeah, let's take a look about how this Copilot session is finding our agent and how it's invoking it.
Yeah, so Copilot, in the Copilot agent, we exposed a tiny A2A directory as an MCP server, and we added two tools, the search agent and the call agent A2A tool. This is the information that Copilot uses to search for an agent in the directory and invoke the agent via the A2A. Now let's go back to the terminal to see what Copilot is doing.
So let's pause here for a minute because like there is a lot of composition happening here. So we are in Copilot Studio, sorry, in Copilot CLI, a completely different runtime. This Copilot session, it searched for an agent using our MCP server. It looked through the directory with all the available agents that are available there. It found one, if you see the line like search agent, it found one agent that can actually perform the task that the user asked for. It invoked the agent using the A2A protocol, which is actually hosted in Microsoft Foundry, which under the hood is the one that we just built, is using LangGraph as the agent loop model for Foundry. It's calling WorkIQ, which is hosted in an MCP server. It's using that to get access to my inbox, get all the emails, get all the content, use the skill to triage all the content of that email, reply back, and get that answer to Copilot CLI that then used to answer this question. So the beauty of this is like none of these components knew about each other, right? Like, so they will be in isolation, which is composing all of them. So that's the story, that's the open source story that we wanted to tell in this demo, how you compose each of these modules using open source standards, and then you can compose a bigger solution by using those open interfaces, so you're free to change them at any time. So that's the story we want to tell with open source. That's the story we want you to take away from this session. So I think it's a wrap. Thank you everyone for the time. I'm going to stick around here for questions if you have it. But you can check out the repo. We have there all the content that we were showing here, all the different stages of the agent as we were moving forward. So you can play with that and see the results. Thank you.